And one of my favorite examples, one of the most tasty examples, is the donut. The donut is basically, if you think about it, it's one little circle. It's a circle, like so, and then somebody took and cut the inside of it out of it. So we'll basically have the area of this entire big circle, then we're going to subtract out the area of this inside circle. And that's basically how a donut works in theory, is that they make it and it's just one giant solid roll, and then somebody comes through and subtracts the center. And that's what we're going to do. Is we're actually going to work with figures today. We're either going to take, area 1 plus area 2, so that we're adding two areas together, or we're going to take area 1, like the area of the big object, like the roll, and we'll subtract out the area of the small object, which is like the center of the circle or the donut hole. So some of them are going to be additions, and some of them are going to be subtractions. And that's basically what a composite figure is. It's either an addition or a subtraction. So the idea is we're going to first determine the individual shapes. So we're going to figure out what shapes make up this composite figure, and we're going to find the area of each of the shapes individually, and we're going to either add or subtract them as we go along. So when I picture this as obviously I picture it as a square with about half a circle on here. So what I need to do is I need to kind of get a game plan to start off with. So I'm going to find the area of a square, SQ, and I'm going to add to it the area of not a whole circle, but the area of half a circle. That's my abbreviation for area of a circle, and that's obviously half of it. So first I come up with the game plan. I think just like in sports, it's always a good idea to have some sort of game plan before you just jump out there and try your luck at things. Next, I'm going to substitute in my area formulas. So I'll just write down the formulas. Area is for a square is s squared. Then I'll say plus 1/2 pi r squared, because that's what we have for a circle. The third thing I'm going to do is I know that I have an s, I know I have an r that I need to find, so I'll come over to this picture and I'll try to identify the side length of a square. Well, for me, the side length of this square is going to be 6 feet. And then I need to find the radius. So the radius of my circle, maybe this is a little bit more complicated. This would be our center of our circle, and if this is 3 and this is 3, that does make up the 6 that's across from it. So I would say my radius is going to be 3 feet. Now the fourth thing I'm going to do is I'm just going to substitute. So that'd be 6 squared plus 1/2 pi times my 3 squared. And the last thing I do is I just basically calculate this number. We're going to round to the nearest tenth, as the directions say. And if you're doing this along with me at home, you should get 50.1 feet, square feet. Circle our final answers just so everyone knows what our answers are. That's the same process I'll go through for the entire thing. I'll have some sort of game plan. I'll write out the formulas for each one of them. I'll come over here and I'll find the actual lengths. I will substitute them in, and finally I'll calculate it. It's a 5-step process. Writing out having a game plan, writing out the formulas, finding the lengths that I need, substituting, and finally finding the actual area. For the second shape, my game plan, if I notice there's a square here, so I'll have to find the area of a square. And there's a triangle over here, and there's a triangle over here, and both of them seem to be have the same height, same base, and the same height. So I'll just say that plus the area of 2 triangles. Not just one. You could write it as area of a square plus an area of a triangle and an area of a triangle. But since these two are actually the exact same length, we'll just go and say that they're 2 triangles. So then I'll write out the formula. Area equals, again, s squared plus 2 times 1/2 base times height. I'm going to come over here, I'm going to find this. The side of the square in this terms is now 8 yards. The base of my triangle will be this length, which is also 8 yards. And the height of my triangle, sort of from here up to here, is illustrated with this 3 yards down here, so my height is 3 yards. I'll then substitute, so that's going to be 8 squared plus, and this looks funny to me, I have 2 times 1/2. Well, 2 times 1/2 is just going to give me 1, so when you multiply by something by 1, you're just going to get this piece right here. So then I'm basically just doing base times height. So that's 64 plus 24. I don't even need a calculator for that. That should be 88 square yards. Again, what we did is we went through, we had our game plan, we wrote the formulas, we found each one of our lengths, we substituted, and we finally calculated in the very end. Some people think this looks more like a pencil, but really if you look at it, it's basically like a rectangle, and then there's a triangle on top of it. If you notice, there's a lot of different lengths on here. This is 10 for the base, which is also going to be the base of our triangle. That 10, it carries over. We have 18 for the length of the rectangle, and we have 30 for the entire length of the pencil. So what we need to do is we need to basically figure out what this height of this triangle is going to be. It's not 13 because that's sort of a slanted height, or just the side length of the triangle. We have to think the whole thing's 30, but just part of it's 18. That means there's only 12 meters left for this, because 18 plus 12 will give me the entire 30. Okay, so I have the area of a rectangle plus the area of a triangle. Area formula for a rectangle is just going to be base times height. Area of a triangle is going to be 1/2 base times height. I'll come over here, and for my rectangle, maybe I'll just split this into two areas here. This will be my rectangle things. These are going to be my triangle pieces. So for my rectangle, my base might be 10. My height might be 18. For my triangle, my base is also 10, but my height is 12 meters. I'll then go through and I'll just substitute these. The base of the rectangle, again that's 10 times the height of 18. This would be plus 1/2, 10 times 12. Lastly, I'll just put this all into my calculator, and when I calculate this, this is 180 plus 1/2 of 120 would be 60, so I should get 240. These would be square meters. Some people say this next shape looks kind of like either a like one of those beakers you might use in chemistry class, where I think it kind of looks like a power plant, like a nuclear power plant for this. And again, there's two shapes involved. Hopefully your brain's starting to see this. There's a rectangle on top and a trapezoid on the bottom, so we'll find the area of a trapezoid. We'll add to that the area of a rectangle. Several different formulas for area of a trapezoid. The one that I prefer to use is 1/2 h b1 plus b2, something like that. The area of a rectangle is just base times height. We have to find these bases and heights. The base over here is going to be 10. The height of our rectangle is going to be 6. For our trapezoid, base 1 would be 10. Base 2 would be 20. That's just down here. And then we need a height. Well, the whole height is going to be 18, and this height is 6. So I think that remains, this part right here is just going to be 12, because 12 plus the 6 gives me the entire 18, so it's going to be a height of 12. I'll just go through and I'll substitute. We'll say 1/2 of 12, and then 10 plus 20 is what we're going to multiply that by. This would just be 10 times 6. Let's see, 1/2 of 12 is 6. 6 times 30 gives me 180 plus 60. Again, I have an area of 240. This time they're square centimeters. This last shape we're really going to kind of concentrate and realize that you can have more than one game plan. Sometimes the Packers go out and they have a very strong offense, and sometimes they're definitely a throwing offense. Sometimes the Packers come out and they're they have a really strong defense, and maybe they're running games on. Either way, they can still win games. They can still have a good time. They can still be successful. For us, when we have a game plan, sometimes you can have multiple game plans, and different students have different ideas of what these shapes could form. And as long as you're adding up all the pieces, I think you're all right. The way that I see this is an area of one rectangle. Some people will split these also like this, and then it's the area of this half a circle and this half a circle, which is really the area of one full circle. Sometimes you can have areas of half circles or whatever else, but it totally works out on its own. So the area is base times height plus pi r squared. I'll then come over here, I'll say, well, the base of the rectangle is 15 and the height of the rectangle is 5. I then need to talk about the circle, the radius for the circle. This is a little bit more complicated. If this entire length is 15, I can subtract off 3 to get 12, another 3, and it turns out that this whole part right here is 9. So the diameter is 9. So how much would each radius be? Well, that's right, it's going to be 4.5 and 4.5. So 4.5 and 4.5 add up to the 9. If I add all these across, 3 plus 4.5 plus 4.5 plus 3, I should get this entire length of 15. So again, my radius is 4.5. I'll simply substitute each of these numbers in here. 15 times 5 plus pi times 4.5 squared. When I put this in my calculator, area should be 138.6 square millimeters. This is a sampling of some of the ways that you can add areas together for composite figures. We're now going to look at some where you're going to have to subtract them. And generally speaking, you're going to have a shaded portion. These are the ones that look like donuts. So the idea with all of these is you're going to have to take the area of whatever the big object is, and you're going to subtract the area of whatever the small object is. What I mean by big object is I talk about sort of what makes the outside. If this was a picture frame, the picture frame itself is a rectangle. The picture on the inside is the triangle. So picture frame is rectangular, the big shape. The triangle is what's inside the picture. It's the small shape. So for my game plan, I'm going to find the area of a rectangle, and I'm going to subtract the area of a triangle. I'll find the units here. My base, actually for both of them, is going to be 30, and my height for both of them is going to be 20. So that's kind of an interesting concept there. Area is base times height for this one, minus 1/2 base times height. So that'd be 30 times 20 minus 1/2 30 times 20. 30 times 20 is 600. Half of 600 is 300. So my area should be a total of 300 square centimeters. Next I have two circles. This is the donut example. You have the area, sort of the big circle minus the area of the small circle. The radius for the small circle is the 16. The diameter for the big circle, is this 40 meters out here. So half of that is going to be 20. So I have my two radii. Again, area equals pi r squared minus pi r squared. And this is where you really have to keep track that you're doing the big one minus the small one. So this would be pi times 20 squared minus pi times 16 squared. When you put this in your calculator, it should be a little bit over 400, 452.4 square meters. That is a big donut. Our last example here is we have our big object is a rectangle, and we're going to subtract out the two circles on the inside. So we have an area of a rectangle minus the area of two circles, and they appear to be the same size circles since they both have a radius of 10. Let's find some of these. Here's the formulas. Base times height minus 2 pi r squared. The height of this rectangle is pretty easy to see. It's 40. The radius, this 10 is the radius here of the circle. So that means that this is 10. That means that another radius right here would be 10. Another radius right here would be 10. And this radius over here would be 10. So that's 10 plus 10 plus 10 plus 10. Oh, that gives me a base is also 40 inches. So this isn't actually just a rectangle. More specifically, it'd be a square. So we'll have 40 times 40 minus 2 times pi times 40 squared. When we throw that into our calculator, our area is 971.7 square inches. Again, all we're doing, the area of the big object minus the area of the small objects. I always think it's a good idea to have a game plan, to write out the formula, to come up here and find the actual lengths that you're looking for, to substitute, and actually calculate the areas. Again, you can think of this, there's a lot of different shapes, but really if you just concentrate on the idea of the donut, I think you'll be happy, you'll have a tasty surprise.